Alright, so in this section, section 4.4, we are going to look at properties of logarithms. So these properties are going to enable us to do a few things as we move into the sections after this one. So we're just going to spend a little bit of time working with them, and we're basically going to do two kinds of problems here in this section, and we'll look at those here in a couple of minutes. But first, let's get to the properties. The first two properties are really going to come into effect when we start solving equations. In fact, we don't even have anything to do with them here in this section, really. The first property is called the one-to-one property, and it just says if you have two logs equal to each other, if they have the same base, that implies that the stuff on the inside is also equal to each other. And hopefully you can kind of see where that might be useful going forward. When we start solving equations that have logarithms in them, if we have the same two logs equal to each other with the same base, we can just get rid of the logs. But that's for another day. The second property is called the log of each side. If you have two things that start out equal, then as long as you use the same base, the log of those two things are also equal. Alright, so those are the ones that we really aren't going to be paying much attention to today, but we do want to look at these other three that I have here. So these other three are going to allow us to kind of manipulate our logs a little bit, to either squish them back together into one logarithm or to pull them apart into multiple logarithms. So the third one is called the product property, and this is for when you have multiplication inside of your logarithm. If you have multiplication on the inside, you can pull that logarithm apart into two separate logs with that same base that you started with, but now you're adding those logs. So we had the log base b of m times n, now we have log base b of m plus log base b of n. Please note, there is no property that will allow us to pull apart addition inside of a logarithm. Okay, you can't do that. It doesn't work, ever. The next one, property 4, the quotient property. This is similar to the last one, except now instead of having multiplication on the inside, we have division. And instead of it turning into addition, it's going to turn into subtraction. So the log base b of m over n is equal to the log base b of m minus log base b of n. And then finally, we have the power property. If you have something raised to a power, this one's actually really nice. The log base b of m raised to the r power is equal to r, you can just put that exponent in front, times the log base b of m. And so where we're going to go from here is we're going to see how we can use these properties, these last three properties, to either take one logarithm and pull it apart into several pieces, or several logarithms and stuff them back into one. And here's why we're going to use each of those things. Now, pulling logarithms apart doesn't really have a whole lot of use for us in college algebra, but it does have a lot of use, or has some use anyway, if you go ahead and take calculus. So for those of you who are planning on moving on and taking calculus at some point, pulling logarithms apart is going to come back. Okay, so we'll see that here in this section, and you'll be prepared then to do it when you see it in calculus. Putting them back together is going to be super useful when we start trying to solve equations. Again, it's going to kind of come back to this property here. If we can just have a single log on each side of our equation equal to each other, we get to get rid of the logs. And so being able to put them back together is going to be useful. All right, but for now, we need to look at how we pull them apart and how we put them back together. So I'm going to do a longer problem first to get us started, and then I've got a shortcut, and it works really, really well. So hang on while I change my board. Okay, so my first example, I want to expand this logarithm, and that's usually the set of directions that you would see for this. Expand the logarithm. So what that means is take one logarithm and end up writing it as a whole bunch of logarithms, okay? Now, I took the time and did this in really what is a longer method than what we need. So I'm going to walk you through what I did, but then I'm going to give you the shortcut, and I think you'll be pretty happy with it. So here we go. The first thing I dealt with is the fact that I have a piece on the top and a piece on the bottom, so this is a division problem on the inside. So I know that when I have division inside of a logarithm, the quotient property says I can split that up with subtraction. So I have a log 3 of the top, 3x squared, minus log 3 of the bottom, y squared z cubed. So then I can take my multiplication that's on the inside and split that apart. For the first logarithm, that's pretty straightforward. I get the log base 3 of 3 plus the log base 3 of x squared. But I have to be careful with the second one because I have a minus sign in front of that. So when I split up this multiplication, it turns into addition, but I'm subtracting both of those pieces because these two pieces together came out of this one log that was being subtracted before. So I do have a log base 3 of y squared plus log base 3 of z cubed, but I have a minus sign in front of that whole thing. So now we're almost done. I changed my log base 3 of 3 to 1 because if the base and the thing on the inside match, it's always 1. And then I went down the line and I dropped my exponents. So the 2 goes in front of the log 3x, the 2 goes in front of the log 3y, but I also distribute the minus sign. And then the 3 for the exponent for the z here goes in front of its log, and again I'm distributing that minus sign. So we can do it that way, and it works out nice, and there's a lot of nice work that you can see, and it works well, but here's the thing. What I really want you to notice is this. These two pieces, really pay attention to this one here because it's a little easier to see it. These two pieces are both positive. The things on the inside of them, the 3 and the x, were the pieces on the top of the fraction. They're both positive, right? This is a positive 1, this is a positive 2 log 3x. The two pieces that were on the bottom, the y squared and the z cubed, here they are, and we did the same thing. We put their exponents in front, but now those have minus signs. And that's really the shortcut. Anything that's on the top, you can just pull it apart, and those pieces will be positive, and anything that's on the bottom will end up with minus signs. Now, you have to be a little bit careful. Again, this only works with multiplication and division and powers. That's it. If you have any addition or subtraction inside of your log, you can't do anything. You're stuck, okay? Unless you can factor or something to turn it into a multiplication problem. So there we go. That's how we expand a logarithm and pull them apart. Do those problems in the book, and you'll get the hang of it. It really works pretty good. So now I want to reverse the process. I want to take a logarithm or a problem that looks more like this one down here at the bottom, and I want to go back to the top. But that's on the next board. Okay, so on this one, I want to condense or write it as a single logarithm. Either set of directions is entirely possible that you'll see. So I have 2 log base 5 of x plus 1/3 log base 5 of y minus 3 log base 5 of z. So using the shortcut that we talked about last time, I know that positive pieces, these two guys, are going to end up on the top of my fraction, while the negative piece is going to be what goes on the bottom. Now, I know that these numbers in front all turn back into exponents, so you can see I put this 2 back on the x and get an x squared. I put the 3 back on the z and get z cubed. Right, we're putting these back in as exponents. But the one I really want to focus on is this 1/3. We have a third, we can bring it back in and put it on the y. But here's the thing, y to the 1/3 power is the same as the third root of y. And so that's how I took this one in the middle, the 1/3 log base 5 of y, and turned its piece into the third root of y. So again, we took our addition and subtraction, we smushed it back into one logarithm. Notice again, I didn't put it back in with any addition or subtraction. And most importantly, I only used one logarithm. Sometimes when there's subtraction, which makes a fraction, people want to have a log on the top over a log on the bottom, but that's not how it works. The fraction is inside of the logarithm. So there you go. That's properties of logarithms. Hope you enjoyed it. Have a great day.